Last day we got to example 4. I like this question. I like this question. I like this question. In that a classic application of choose is forming committees, forming groups. Because if I'm a little bit clever, I can turn almost any question into a committee question. The same way with permutations, if I'm a bit clever, I could turn it into a word, which is why we started scrambling letters so often. So example 4 says this: a planning committee is to be formed for a school-wide Earth Day program. There are 13 volunteers, 8 teachers, and 5 students. How many grand total people? Read. How many grand total people? 13. How many subgroups are there? 2. Draw yourself a bucket, because we said this was going to be our strategy for choose. What are the 2 subgroups? Teachers, students. How many teachers are there in the bucket? How many students? Okay, I've got my setup. I'm going to keep reading. How many ways can the principal choose a 4-person committee that has at least 1 teacher? How many people on the committee grand total? No, that's how many people in the group. How many people on the committee grand total? Read carefully. 4. And what's the condition that has what? No, it's not one. Read carefully. There's a key word. At least 1. What does at least 1 teacher mean? It means 1 teacher or? More specific. 1 teacher or?
2.
Or?
3.
Or?
4.
Or? Can I go 5?
No.
Why? Oh, because how big is the committee?
4. It's 4.
Okay, you guys with me? Okay, we got to focus. You're going to have to be able to get these numbers. That I can't teach. You're going to have to be able to figure this part out. I can teach you how to solve it once you get the setup, but the setup you're kind of on your own for. So I got my bucket. It's going to be a total of 4 people, at least 1 teacher, and here's what I would write, and this is where I would not take shortcuts. I would say this: 1 or 2 or 3 or 4. We say there are cases, there are different cases, and when there are different cases, or at least, or more than, or less than, I always list them all. It takes 1 second, but trust me. And who remembers what I said last day? What does the word or mean? Nope. Or means add. And means times. Or means add. So it's going to be a plus sign here, a plus sign here, and a plus sign here. How many teachers in the first condition, in the first case? How many teachers? 1. So it's going to look like this. Arrow, 1 teacher. How many students then? Rachel, how many? 3, got it. Do you remember how we translated this into choose speak? What choose what? What choose what? 8 choose 1 and times what choose what? From 8 teachers, choose 1, and from 5 students, choose 3 of them. Doesn't mention order, doesn't talk about first, second, or third, so I know it's a choose. In fact, a committee question is going to be a choose unless they start talking about specific positions within the committee, like president, vice president, secretary. Well, then the order matters. What's the next case? How many teachers? How many students? Translate it. What choose what? What choose what? 8 choose 2 and 5 choose 2. Or how many teachers?
3.
How many students? 8 choose 3 and 5 choose 1. Or how many teachers? How many students? 8 choose 4 and 5 choose 0. Now, the best way to do this, Sean, can you show Jacob where this stuff is on his calculator? I want to do this with the easiest, most accurate, but also least amount of typing. So I'm going to go into my run menu. I'm going to go hit option. I'm going to bring up the probability stuff. You might still have yours already. I'm just going to type the first expression, the first case. 8, choose 1, and 5, choose 3. And I'm going to hit enter. What's that first one work out to? Where would be a clever place to write that? Right underneath? Sure. 80 plus. And then rather than retype this, I'm just going to backspace. What do I want to change that 3 to? In the next one. And what do I want to change that 1 to? That's way easier than retyping everything. And I'm much less likely to make a mistake because I was careful in my first typing. I made sure I got everything typed in right the first time. 280? Yes?
Yeah.
3, no, 1, Mr. Dueck. 1. Dope. Let's try this again. Here we go. 1 and 3. Also 280? Okay. Is that right? And the last one is going to be 4 and 0. 0, 4, 70? What's the answer? Sorry? 710? Now, right now, Rachel, you may be saying to yourself, and I would totally understand this, what a useless question. Why would I care how many different committees there are? Because I can turn cards into committees with a bit of cleverness. Instead of teachers and adults or teachers and students, how about clubs, diamonds, spades, and hearts? Oh, you'll have 4 groups in your bucket. Okay. So I'm going to, where it says pause here, homework, I'm going to assign some of that homework later on, but I want to continue with the next lesson because I'll teach you today how to count cards. So continuing on, lesson 5, I call this applications of combinations. One of the best ones, and I'll be honest, yeah, cards, because you don't care when you get the ace. All you care is if you have the ace. It's a choose. Cards are choose. So I need to explain what a standard deck of cards look like because not all of you may be familiar with it. So a standard deck, the one that we're going to talk about, has 52 cards with 4 suits, spades, spaces, Mr. Dueck? I need to fix that, apparently. Spades is what happens when I type in a hurry. Hearts, diamonds, and clubs, 13 cards each, because 52 divided by 4 is 13. How many clubs are there? 13. How many hearts are there?
13.
How many spades are there? 13. How many red cards are there? 26. Half the deck. How many black cards are there? 26. That's about the way we're going to divide these into groups. Oh, wait. What's a face card? Foster.
King, queen, and jack.
We call them king, queen, or jack. We call them face cards because on the card there is a face. How many face cards are there in the deck grand total? Think about it.
12.
Why 12?
Because there's 3 of each color. Sorry, there's 6 of each
Three,
color.
well,
3 of each.
3 of each suit and 4 suits, 12. Okay. And face cards are interesting because those are the higher value cards. So we will do some questions involving face cards as well because I want to know. Okay. I know right now, since I created this lesson, 7-card Texas Hold'em has become very popular. 7 cards, the numbers get so big that they start to become weird on our calculator. So I'm just gonna focus on 5-card poker. Okay. So how many different 5-card hands can be formed? How many cards are there? Grand total?
52.
52. How many are we choosing in part A?
5.
Which is what? How many 5-card hands can you form? What is 52 choose 5?
2 million, what number?
Can you read me the digits? What?
2, 5, 9, 8, 9.
25989. I remember almost 2.6 million. 2,598,000. Okay, almost 2.5 million, really, if you want to rough. Okay. How many different 5-card hands can be formed that consist of all hearts? This is a job for a bucket. And we have 2 groups. Hearts and others. How many hearts are there in the deck? 13. Do some arithmetic. How many others are there in the deck? 39. How'd you get that? 52 take away 13. Okay, you have to do some subtraction. Sorry. 39. In this question, how many hearts do we want to pick? 5. How many others do we want to pick then? 0. How many different 5-card hands can be formed that consist of all hearts? What choose what? What choose what? From 13 hearts, choose 5 of them, and from 39 others, choose none of them. Now, ready for your first? I think we did this last class, but what's anything choose 0? Do you remember? 1. So I'll write it out. I always write it out because one of the things you're going to notice, Sean, is there's usually a built-in error check where if you add this and this, you get 52, and if you add this and this, you get 5. You get this little template right here, and I like that built-in error check. It makes me know that I didn't miss anything. But if I'm typing it, I'm just going to go 13, choose 5. 1,287? By the way, what do you call a hand with all hearts? What do you call a hand that's all the same suit? A flush. How many ways are there to get a heart flush? 1,287. How many different suits are there? 4. How many ways are there to get any flush? Oh. There's 5,148 ways to get a flush. We'll write this down later on, but if you're wondering how we're going to figure out some of this stuff, that's how we're going to get to. C. How many different 5-card hands can be formed that consist of all face cards? This is a job for a bucket. I'm going to have face cards and others. How many face cards are there in the deck? Remember? 12? All right, do the arithmetic. How many others are left in the deck? 40? 52 take away 12? Really, it's 40. Trust me, because it works out. Oh, anyways. Yeah, whatever, I believe you. How many face cards do we want, Tiff? 5. How many others? Okay. By the way, what if I wanted 4 face cards? Can you see it would be 12 choose 4, 40 choose 1? I can modify this into whatever you want me to, but I start out this bucket. I think I told you the other day when Ted Bentley, the prophet, Capilano, showed me this bucket approach, I was, oh, that's a nice visual, great hook, because I used to do this all intuitively, and it was kind of tough to visualize. Now I can see it. What choose what? What choose what? 12 choose 5, and from 40 others, don't choose any of them. 792? Now, a hand with only face cards is nothing. Oh, unless some of them match, then you have a pair or 3 of a kind, but that's not what I asked here. I just said, how many ways are there to get face cards? Okay. How many different card hands can be formed that consist of 3 hearts and 2 spades? Now I'm going to have a bucket with 3 groups. No, Mr. Dueck, just 2 groups, hearts and spades. No, hearts, spades, and others. My bucket's going to look like this. Hearts, spades, and others. Can I abbreviate others with OTH? How many hearts are there in the deck? How many spades are there in the deck? Do the arithmetic, preferably without a calculator. How many others are there in the deck? Huh? Oh, half the deck, 26, right? Okay. Erica, how many hearts do they want me to choose? Yep. Yoink. How many spades do they want me to choose? Erica, how many spades? Two. How many others? Trick question. As a number, please. Zero, thank you, because shaking your head they can't hear on the internet. Hey, Erica, what choose what choose what choose what? And what does and mean? Multiply. This is why and has to mean multiply, because you're saying I want to get 3 hearts and 2 spades. What's the answer? If you don't have your calculator out, you might want to get it out. Just saying. Forgot his calculator. Oh. Hey, what's the answer? What is 13 choose 3 times 22308? Okay. E. How many different 5-card hands can be formed that consist of exactly 3 hearts? How is D and E different? Well, in E, I was also saying you had to have 2 spades. In E, I don't care what the other ones are. So now my bucket's going to have 2 groups. What 2 groups in my bucket? Hearts. Others. Try this one on your own. I'll do this here. Let's see if we get the same thing. See if you get what I got. Yes? Yeah. Okay, you see you got it right. If you're picking 3 hearts, you're automatically picking 2 others, right? So you're picking 5 cards grand total. By the way, Jacob, you seem to know something about cards. 3 hearts. Is that a useful hand in poker? No. That's why this is such a big number. There's lots of ways to get 3 hearts. The smaller this number, the better the hand. The fewer a number of ways you can create the hand, the more the hand is worth. Okay. Pardon me? Patience, young grasshopper, patience. Turn the page. Roy. Okay. How many different 5-card hands can be formed that consist of at least 3 hearts? All of us right now, let's underline the word at least. Now, my bucket is going to have hearts and others. Okay. How many hearts are there in the deck? How many others? 39. What does at least 3 hearts mean? I want the cases, so I agree. 3 or 4 or
5.
so we're going to have to look at 3 cases and then add them up. I guess, Brooke, the first, there's 3 hearts. Oh, by the way, how many others am I choosing if I want 3 hearts? So the first one's going to be what choose what choose what? Or, cross that out, cross that out. 4 hearts. And how many others? 1? So what's the second expression going to be? What choose what choose what? What choose what choose what? 13 choose 4. 39 choose 1. Or 5. And I guess none. 13 choose 5. And 39 choose 0. Try this one on your own. See if we all get the same thing. I'll try typing this in one fell swoop. Usually I don't do that. I don't know. Howdy, howdy. I typed it in one fell swoop, and I'm a little worried because I might have made a typo. Is that what you got?
Yep.
Okay, it's really easier to go one term at a time, I find. 241,098. Okay. So, poker hands. Poker hands. What's a royal flush? What's a royal flush? Sorry? You're right. Okay, so all in the same suit. Let's figure out the odds in one suit of getting a 10, a jack, a king, a queen, and an ace. And then since there's 4 suits, I think we'll just times by 4. Okay? How many cards are there in one suit? 13. And I want 5 of them. I'm blanking for a second here. Hang on. All right, we're back. Roy, my friend, how many different royal flushes are there? You can get, okay. So this one, I don't need to do any math. How many royal flushes are there? 4. You can have 1 in hearts, 1 in spades, 1 in clubs, 1 in diamonds. Now, if you want the odds of getting that, because it's just how many, hey, on the previous page in our notes, how many 5-card hands were there? No, how many 5-card hands were there? 2.6 million. You know what? If you want the odds for any of these, you just divide by, that'll tell you the odds. Okay? So if you want the odds of getting a royal flush, it's 4 divided by 52, choose That's in scientific notation. It's 0.000000153. It's pretty small. It's pretty small. Okay? How many straight flushes are there? What's a straight flush? So, 5 in a row. Give me an example.
1, 2, 3, 4, 5, all hearts.
There's no 1.
Or 2, 3, 4, 5, 6.
Okay, 2, 3, 4, 5, 6 in the same suit. In fact, how many ways can you get that? Does the royal flush include the ace?
Yeah.
Okay, so let's start with a 2. You can get a straight flush. Count with me. 2, 3, 4, 5, 6. 3, 4, 5, 6, 7. 4, 5, 6, 7, 8. 5, 6, 7, 8, 9. 6, 7, 8, 9, 10. 7, what am I on? 6, 7, 8, 9, 10. Say 7, 8, 9, 10, Jack, Queen. Not a royal flush, but that's a flush. You can start with an 8. You can start with a 9. You can start with a 10. Oh, you can't. So how many ways are there to get a straight flush? How many ways are there? How many suits are there?
4.
Okay. Whatever the heck that is. There's 32 ways to get a straight flush if you exclude the royal flush. There's actually 10 ways to get a flush, but we exclude the royal flush. Flush. Okay, now we can start using some chooses. Okay? How do you get a flush? First of all, how many cards do you pick? Well, I'll say it this way. To get a flush, the first thing you have to do is pick a suit and pick 5 cards. What does "and" mean? Multiply. How many suits are there in the deck? Choose. Pick a suit. Could be hearts, could be spades, could be diamonds, could be clubs. Once you pick a suit, how many cards are in that suit? The only problem is that also includes straight flushes and royal flushes. So once you figure that out, you would have to subtract 32, and then you would have to subtract 4. Someone's phone's going off. Turn your phone off, please, because that's what that little buzzy noise is. Someone's receiving a text. Trust me, because you're sending out an electric field, and the electric field's interfering with the magnets and the... Anyways, trust me, okay? And it's somewhere near here.
And it's
Oh, it's Roy's. Okay, so pick a suit, pick 5 cards, and you would then divide that by 52, choose 5. Now that includes the royal flush and the straight flush. If you wanted to, you would subtract 4 and subtract 32 and put that number on top. So instead of 4 choose 1 times 13 choose 5, you'd go 4 times 1 times 13 choose 5 minus 36 divided by 52 choose 5. A straight. A straight. What's a straight? Cards in any order, but not in the same color. Sorry, cards in the correct order, but not in the same color. 3, 4, 5, 6, 7. That's a straight. If you have a straight flush, that's better. How many ways are there to get a straight? Well, it turns out you can, starting with ace, you can go ace through 5, all the way up to 10 through king. There's 10 different ways to get a straight. Except for each of those straights, for each of those 10 different ways, you have 4 different suits to pick from in each one. Okay? Except that's one single straight looking at one individual number. It's actually going to be, I got to look at my notes here, make sure I get this right. Why is it 4 to the 5th power? Because I did a lousy job of explaining this. I'll say it this way. It's 4 choose 1 because for each possible card you have hearts, spades, diamonds, or clubs. You got 5 different ways to pick those because you need 5 cards in a straight, and there's 10 different ways to get a straight. I think we're stopping with full house. Good. It gets more complicated the further we go. Didn't say it was easy. Say we can figure this out. 4 of a kind. Our strategy is going to be pick a suit and sorry. Dueck, I haven't taught this for a while. Pick a card. Pick all suits. And pick another card from one suit. Say what? By the way, I don't think I said this. I'm not going to be asking you these on tests because they're tough. Gambling odds are tough. But you guys asked, so okay. Here's what I mean. How can you get 4 of a kind? First of all, how many different cards are there in any one suit? You got 13 different types of cards to pick from. Pick one. Let's say a 6. How many 6s are there in the deck? From 4 6s, you want to pick all 4 of them. There's your 4 of a kind. Oh, except that's 4 cards. I got to pick one more card. How many cards are left to pick from? 12, not 13, because I already used up the 6. Choose one. Except, how many of those cards are in the deck? From 4 suits, choose one. Divide that by 52, choose 2, you're good to go. 52, choose 5, you're good to go. Full house. Full house is pick a card, get 3 of those 4 cards, pick another card, get 2 of those cards. Three 7s, 2 9s. It gets trickier after this, and it's already tricky, but it gets even trickier after this, Emma, because you have to be very careful to make sure you're not accidentally doing what we call double counting. Double counting is when you count the same thing twice, when you count ace-king as different from king-ace, which is not the case in cards. We're going to pause. I'm not going to ask you to do card counting on a test. This is because you guys had asked me. So a little note, we're going to pause here. In terms of homework, can you go back to lesson 4, please, that we started off today with? I think you can try these, but let me just double check quickly. Folks, that's your homework there. You can try those questions. It's on choose. You need to practice this. And sorry, I didn't do the cards at the end there very, very well. I hadn't taught it for a few years, and I should have rehearsed it more. My bad.